Hi guys. Yeah, well, still hot in Vienna here, but it's time for another video. And as long as it's hot, we will get videos with power supplies or something with power. This time, this beautifully made power supply really looks like crap. Look at that. Look at this looks like an El Cheapo something. It's heavy, but look at the specs of that. Hope you can see it. This power supply is a BENNING, a German-made power supply, a 2 kilowatt power supply. That's a lot. It's a 2000 SE Slimline rectifier. I purchased them quite a while ago from eBay, from a Dutch seller, quite cheap. Unfortunately, I cannot find any information on the internet, at least not technical information, for the pinout of the connector or even more some service manual or something, but not even the pinout of the connector. And unfortunately, the seller didn't send me anything. Anyway, this video will be all about this crappy looking power supply here with fantastic power ratings that goes up to 75.6 volts up to 44 amps. That's a lot. From what I know, this thing is controlled software with some kind of protocol externally. They call it a controller that controls it. Ha ha ha, of course. I have no information about that. It should go between 48 and 75.6 volts. We could adjust it, and the maximum output current can be adjusted. So the seller told me perhaps this one is still or is set only to 10 amps output. I cannot test it because I don't have any pinout of the connector that I will show you soon in a jiffy. And I don't want to play with that. But this thing is fully software controllable. It seems that it has 2 pieces of software. So I don't know if it's the primary and secondary means that it's a primary module and the secondary module from the point of view of the software, or is it the primary and secondary side? I have no idea. But anyway, this thing is fully software controlled. Even that it looks crap outside, from the pictures what I saw, it's wow, it's fantastically made here. Yeah, let's take a little closer look of that. I'll show you how it looks front and back. This is the connector. Of course, it's a German, oops, upside down. It's a German-made power supply. Yeah, and they use a very nice connector. I love this connector and I use it a lot. It's called, let me see on what I wrote, it's called a DIN, D-I-N 41612. DIN is an abbreviation for Deutsche Industrienorm or German Industry Norm 41612. And the model is H15 for 15 connectors. And guys, each of these pins can hold on to 15 to 20 amps. Yeah, this is why they use it. So they can, without any problem, deliver 2 kilowatts over this connector. Let me show you a little bit more about that, this connector. This is the female version of one of the female versions. This would connect, yeah, here we have it like that. One moment. Yeah, this happens when you do it in camera. This looks like that, and you could use spade connectors to connect on the back, or This would be this one. Or you could use this kind that have screw terminals. Like that. So this is the connector that they use. And I'm using this connector quite extensively. For example, here with my in my Rötest design. Rötest is one of the most advanced tube testers at the moment existing. Very, very feature packed and thoroughly software controlled. It's an open source project, and this is my version of the socket receivers, where I did. This is my solution with a box. You see this box before in another video on my GPS field strength meter. Here I made one of these boxes. It's a breakout box, and because, yeah, I just have enough space, I added two sockets, a 12-pin and a 10-pin socket, and an outlet for a 12-volt auxiliary power supply that I have used internally. And just for fun, I use 0603. Yeah, what else? Anyway, let's take a look of the power supply. Well, as I said, from the outside, this thing looks like crap. Cheap, but at least zinc plated, I don't know, probably. Heavy metal, sheet of metal, just bent. The problem is, there are no screws. There's nothing. This is just bent, a piece of metal sheet bent to a square and closed with these hinges. No, not hinges, I don't know how to call it. These things. This is the back, and that's the front with a fan, quite a big fan. That's a server fan. Yeah. So this thing is, to open it, you have, look, you have to bend this thing open like that, and then bend the whole. I want to show you the whole procedure. Bend the whole metal sheet back. If you do that 3 times, it's broken. It's gone. Look at that. I had to bend this thing completely. It's so difficult because it's big. Look, if I do that 2-3 times, it's gone. This thing is never meant to be serviced, probably. But look how it looks inside. Let me take out the PCB. Okay, it's out. It's completely isolated with a sheet of plastic, of course, top and bottom. But look at that. This is, I don't know, this is awful. Why did they do it like that? I don't understand it. This has to be like that, yeah? Yep. This is the worst casing I ever saw, but it's a German product. There have to be a reason. Germans never do something without a reason, from what I know at least, yeah? So, I don't know, and I'm sure this is the reason why they did it. It's not the price, because you will see this power supply is internally, wow, what a construction. But let's put this thing away, yeah, and check the more important things, the more interesting things. Look, this is how it looks. Oops, I broke out something. Anyway, let's go near to that. This is how it looks. Let me take this zoom back and show it to you. So, before we go to the teardown or the overview of the power supply itself, checking out what function and what groups, how they designed it, etc. Of course, it's just an overview and a lot of guessing, yeah? Guys, if you would need your help, if anybody of you has information about this power supply, technical information, that means connector pinout, perhaps schematics, informations on how to adjust the output voltage, how to control it, please contact me in the comments. I would appreciate any help of that, because I have nothing. And the second thing is, well, if you like what you see, if you like my videos, please leave a thumbs up. Consider subscribing my channel. Most of my viewers are non-subscribers. Guys, please subscribe. It doesn't cost anything and helps me to maintain the frequency of the videos and the content to be kept as interesting as possible. You see what I'm uploading, the kind of videos I have for everything, almost everything in every aspect of electronics except of audio. I don't know why. I never was interested in audio. Anyway, everything else will be covered. So, if you have any informations about this power supply, what you see here, please contact me and let's continue. So let's have a look. First of all, the input section. Big common mode suppression chocks, 2 of them, X2 capacitors, Y capacitors, etc. Then we have here a small transformer, and this looks like a flyback, and I'm sure it is a flyback. If we turn it around, we see here a top 2955 chip. That's a flyback. It's just generating some auxiliary help voltage. I don't know what exactly, but it's nothing else. Interesting, this. Yeah, that's probably the feedback resistors for something. Looks very nice. They're using MELF. Okay, it's not the newest one, but MELF resistors are far more power resilient than normal SMT resistors. We have here a nice, I wanted to say shunt, but it says F. That means that's, what does it say? F350, yeah. That means this thing is a fuse. Anyway, let's turn it around back. Let's continue. Yeah. Is it the input? Yeah. We are still in the input. The power factor correction, the power factor correction, sorry. The common mode chokes. These are probably XY, Y1 capacitors. We have some nice, very nice, let's see how I can do it, how to do it so you can see it better. R004, that's 4 milliohms, 4 milliohm current sense resistors. I don't know where they put it, but they're really very nice ones. Then, continuing from left to right, let's go back. Yeah, 2 big inductors, That's for the power factor correction. The active power factor correction, the combination of these inductors with the filter capacitors or the bulk bus capacitors make the power factor correction. And probably these are the, I cannot see anything here. It's not really focusing anything, even though I lock the focus. Yeah, anyway, this is far too complicated to show it here. Seems that this side here are the active components of the power factor correction, rectifying and power factor correction. That means that it is more or less universal, not really, I think from 200 volts to 240 volts or something like that. I don't know, what does it say? Yeah, 205 to 240 volts is the input. Power factor, this is a boost converter that looks like that. This is how the PFC, it is just a boost converter. The good thing is that you have the choke here. It means that you have still already some filtering, yeah? And the DC-DC converter, more or less, when it is in the limits of the allowable AC, sees always the same DC voltage here. You can start to chop on the back. This, not only, the PFC not only filters harmonics to the mains, it looks more or less, it tries to, from the point of view of the mains, with the active PFC, a good active PFC, you get almost 90, a few times near to 100% power factor. That's almost 1, yeah? So as near as possible to a resistive, like if you had a resistor here. So that the apparent power and the real power, the factor is 1. That means that you get as most as possible from the mains to the load and not leave it here inside something, yeah? Anyway, power factor correction, but look at this beautiful heatsink. This is not a heatsink, standard heatsink. That's an aluminum core PCB that it used as an heatsink. To be honest, I never saw that before. Look. Very, very interesting. Again, a lot of current sensing, but you know, I don't know why they did it like that. It is so difficult to show it to you because it's not focusing correctly. The whole thing is an aluminum PCB. They use it as a heatsink and as a carrier for the power MOSFETs, diodes, etc. Yeah? Very, very interesting. So this again shows that this thing is not a grab. You see how the thing is built. It is very, very nice built. It's like, it is, yeah, high-tech construction. Not a cheap, I don't know, half bridge with a TL494 or something. Okay, let's continue. We go from the right side. Here was a fan. I disconnected it because it was flapping around in the breeze. So now we're going to the switching. At the moment we have generated here the DC bus, the high voltage bus on these capacitors. We're going to the switching. And from what I see, it seems to be a full bridge LLC resonant converter. This is how something like that looks. You have the switching part that makes the square wave, and you have here the more or less transformer or the coupled inductor, yeah? And here you have the LLC tank with capacitor and inductor. LLC is perfect for high efficiency. It gives you more high efficiency, lower EMI, and higher power density, but it's more complicated to build, of course. So let's see how this would look. Here you have it again in equivalent circuit. The full bridge is here shown as a square wave, the two resonant components, and the transformer itself. So let's take a look how that looks. Look at here. This inductor here, with this big black leads, is the inductor part of the LLC circuit, and probably, I say probably because I'm not sure, these two is the capacitive part. Are they in parallel? It's so difficult to hold it. Yeah, these are in parallel. These two are in parallel. Yeah, probably these are the capacitors of the LLC tank. Again, I'm guessing, but it looks much like that. And and here, the main transformer. Look at how beautiful it's built. Look. Lids wire to reduce the skin effect. This is probably a gate drive transformer for the MOSFETs, for the 4 MOSFETs here. It looks like, let's go back, you have 4 MOSFETs and the rest seems to be diodes. But let's see. Again, we have here this beautiful design of, sorry if I want to show you if it is possible. This is impossible to see. I don't know what that is. It is G something. Let me take a look. Anyway, diodes and MOSFETs. I have to check it later with the magnifying glass or somewhere better. Under the camera it's not that easy. Anyway, this is the other side, the switching side, the switches for the transformer. Not only the transformer, but this circuit here, the 4 switches for the full bridge, the LC. Here we have the L and the C, probably the blue capacitors, something like that. And the main transformer here, this thing. Let me show it to you again, closer. It is very, 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 very nice made. You have 3 outputs here, again with lids wire. Look at this beautiful lids wire here. A nice big transformer. I don't know, it is quite a high frequency that they're switching. Hey, it's written something here on the transformer. PQ40/30, whatever that means. Anyway, this is electronics porn. Anyway, here we have the capacitors, the output capacitors. Again, common mode, big common mode jog. Look at this thick wires. I think it is 1.5 millimeter. Same here. This is probably output enable, disable. This is quite a beefy relay, just on off. And what it seems here, it looks like fuses, car fuses. And again, filtering at the output. And there is a lot of logic here. Let's go near, more near. It's a lot of logic. AD7324. Microcontrollers, that's the resonator for the microcontroller. Again, some chips with, looks like some firmware burnt in, and the same another controller here, etc. Anyway, this is probably what it says. What it says here, software primary and software secondary. Does it match? 484.80. Let's see if it matches anything. Well, not really. Not really. But anyway, I think this has to do with that. Yeah, well, this is the front, and this is the back again. Let's go way back to see it. Really, really beautiful. We have it better here, like that, perhaps. I will show it to you again. Beautiful, high quality components. I checked out a few of the power components. We'll start with a rectification with two of the DSP-8-08S double 800 volt rectifiers, two of them to make a bridge. These are these two here, that and that. Then we have a MOSFET, and to be honest, I don't know why they use it. It is this MOSFET, a 650 volt power MOSFET. Then this is the one behind the relay here. Then we have the real MOSFETs, these two. No, sorry. These are the switching MOSFETs. These are the switching MOSFETs here, what I showed you, these ones. The one behind the relay is this one, an IRFBE30, again a high voltage MOSFET, don't know what it is for. After that we have the two switching MOSFETs in parallel probably. These are these two, this and this. And then we have the rectification, the diode itself. Let me show it to you. That's a good one. Look, whoops. Electrons fall out again and again and again. This. It's a silicon carbide Schottky diode. A nice one. Never used one of those before. 600 volts, 6 amps. Then we turn the power supply on the other side. Here we have 4 transistors. This is the full bridge itself. And these are these ones. Ooh. 650 volt, 0.099 ohm, that's low, very low. Okay, these are the 4 transistors for the bridge, the switching bridge. And then we have these 3 MOSFETs here. Seems this is an synchronous rectifier. Makes a sense at this power, yeah. Secondary rectification, synchronous secondary rectification. And we have these ones. 150 volt, 7.2 milliohm RTS on. So, chip. Beautiful components. This baby is a beauty, to be honest. Yeah? I like it. So the complexity is of course high, really high. But you see it is from a time they used MELF components mostly for the resistors. Well, this is more or less what I can show you today about this power supply. I want to use this power supply as the supplying PSU for my design that I plan making an variable AC power supply that would be between theoretically zero and 400 hertz output, and 0 again theoretically, and 300 volts AC up to 1 kilowatt. And I bought this to be the low voltage supply for that, because you need a lot of power if you use a pure sine converter with a low voltage input. Of course, the other possibility would be to use a pure sine inverter with a high voltage, high frequency input, high voltage input. It is a pure sine inverter, high frequency pure sine inverter. Then you need at least 300 volts on the switchers. But I want to use a transformer at the output just for safety. This is why I want to use this. Okay, this is what I have today for you. This is really, really beautiful made. I cannot say anything, and honestly, it costed to me $30, or sorry, 30 euros plus shipping. Good thing. But I have absolutely no information on that, on the pinout of this connector. So guys, if you have any information, again, regarding this power supply, technical nature of course, pinout, how to control how to adjust the output voltage to control the output, or adjust the output current. It's all done by software, what I read, from this ominous controller that you should use. This would help me a lot. And again, please give me a thumbs up if you like what you see. Subscribe my channel and press the notification button so you get informed when I have new videos. Again, wish you a nice summer. We will see you again soon. Thank you for watching. Stay safe. Till the next time. Cheers, guys. Bye.